All right, good morning. Um, Looks like we got everybody almost here. So we were in here last week. I wasn't feeling well, and we left off on commercial plumbing, light commercial plumbing, and we were in the stage of another plumber replacing a urinal. And I was gonna play part two for you. So if we don't remember what happened the last time, he pulled it off. It was broken. It was leaking in the back, but this was just a scenario of what you could run into and having to remove one of these fixtures and how to get back on there. So I'm just gonna continue with that. So this is part two.
Hey guys, welcome back to Plumbing with Tim, part two of urinal replacement. Today we're back over at the condo association in the clubhouse bathrooms to rehang a brand new urinal. As you saw in my last video, the urinal actually got broke. The dog ear was. We didn't do it and stuff. But we are being graced by another one of our plumbers from our company with his helper. So there's actually 4 of us on the job. So if we can't get it done, it's never getting done. Let's go. There's a new urinal. I think we got a problem here though, because this urinal looks to be a little bit bigger than the other one. From the dog ear point, the center point is 23 1/4 on that one, and up here where our old one hang brackets are around, let's see, have some patience here. Looks to be right around 20 1/4. So we have about a 3-inch difference. It's telling me we're gonna have to move those brackets up a little bit. And I don't know if there's a backing board behind there. There is on that, but if there isn't a backing board on there, we're gonna have to call and get some long toggle bolts. But 3 on the other side. And take your level and draw a straight line across the 2. That way we know exactly where we're raising that bracket up to. And I don't think there's any backing behind there. There we go. Sounds like there's a backing board back in there. All right.
Just catch you on the side front.
All right, lining up our closet bolts coming off our flange before we put our black seal on there. We've moved the brackets up a little bit. We're going to add a couple more screws in there. And we're going to try to hang this bad boy from the wall and see if it all matches up. We got our wax seal down in here. Make sure it's, take your palm and kind of press up against it just a little bit so it holds tight. Okay. That's good. Oh, wish me luck. Need a lot of it when it comes to hanging these journals. Hang a bracket first. Get it on there. And right about there. Should line up on the bottom. Where am I? There it is. There she goes. Nice. Now we just need to get the nuts down here on that and hook up the valve. I see this little bit of a space that's in here. It's because that flange is away from the wall a little bit. Not too worried about that as long as it's sealed to that wax. We put some rubber washers on there first to protect the porcelain. And like that. And our screws. Yeah. Let's do it. Now I want to be careful. We're working with porcelain. It's like a toilet. Ever tighten something, it's going to break. I'm telling you right now. We'll get these tightened down, and we're going to hook the valve up and see if we got any leaks, and we'll seal it all up. I know we're going to have to make some adjustments here on the valve pipe. What's that, big guy?
Yeah, Don.
I heard all that. You taking that thing and throwing it on the floor. Back here, little O-ring gasket that goes there. The valve is shot. Got a kit here. Let's see if something like that'll work or not. I don't know. It might be too big, might be too small. It's kind of sloppy. Looks a little bit big. Let's keep trying. Kids here, trying to get this thing lined up. Let's go. The automatic light just went out. You guys can see. Oh yeah. Very nice. All right, so we had a lot of adjustments to make, as you can see. When you change out a urinal, it's never the same footprint. Also, I believe that a little bit of the wax got stuck in here because when I first flushed this, it wouldn't go down. So I got that cleared out. I had no problems with that. And the valve had a hard time lining up, and the washer up in here was bad. I was luckily I had one because all the parts stores are closed right now. But everything's working great. And no leaks. Maintenance guy will do the rest. That's all the time we got for this one. I wish I could have been a little more detailed with you, but we had some visitors.
Where are you going? Stop.
All right.
Just go to the bathroom or not?
Is there any questions on I don't know, maybe a scenario you went through and or any other things that you guys want to add to that?
I'll make a urinal comment.
Okay.
What I'm noticing is on these 1.0 urinals, they're not like back before when the trapway was a lot bigger. I think what's happening now is to try and pull that thing off the wall and clean it and get all the calcium buildup out of that urinal probably takes more time than to just figure you're going to go and replace that urinal, especially when the urinal itself is plugged, not just the drain behind the wall. If you have something that's real heavy built up, like behind the wall, I think it's a better step to just let the customer know you're going to replace the urinal and then jet or cable the drain. If it's just a stoppage and you've run water through the urinal itself and it's flowing properly, then no big deal. But if you have a plug in the urinal, trying to clean that out from that small port, and get through the trapway 100%, it's really tricky. And it's not worth scratching it up and the effort and labor you put into it. I'm going to say they're probably about $150 as far as the urinal. You know, the cost of the urinal versus a replacement at that point, you know, let's just say most of the time they're probably going to have had it in for at least 5 years at that point. You know, it should be time for a new urinal. I don't think you get too much resistance on that. It's just an easier procedure. It's cleaner. It looks better when you're done. Customer gets better product versus you spending a whole bunch of labor trying to clean out something that may not be 100% when you're complete. That's just something that I've noticed over time.
Yeah, so there were some other things in that video. I mean, if you're gonna have to, ruin the wall like that, it's always good to make somebody aware of what's happening before it happens and not such a surprise. Um, so that pretty much covers the light commercial side on dealing with uh a multi-fixture bathroom like a public restroom, and the other light commercial drainway system that you know we deal with is the commercial kitchen, restaurant style, whether they're in hotels, any kind of restaurant, any kind of commercial settings. We all have been in one of these. Do you guys know the difference between indirect and direct drain? So the difference between an indirect and a direct drain is that the direct drain is directly connected to the source, to the drainway system, which is also connected to the vent. And, goes, let me just get this up. It's directly connected to the drainway system. So it's got a trap on it and it's directly connected. And then in an indirect system is where it's dropping into like a floor sink or another drain. What makes it indirect.
Why would you use one versus the other?
I guess the access and everything makes it easier to get to. What do you think?
Maybe you can, because you can add multiple fixtures as well.
Yeah. If any times restaurants got to add things to, their facility, they have all these drains that they can get to. You don't have to be opening up walls, stuff like that. And that's just on the drain side of things.
And then the height. Explain the difference between a floor drain and a floor sink.
So the floor drain, which is this one here on the left on the floor, that is what collects anything that ends up on the floor. The floor sink is only made to pick up what's coming out of your fixtures. So you don't want your floor sink below your tile level because now everything's going to get washed into there. That just becomes a collection of just all the, the garbage on the ground and stuff like that. So some of these drains don't have, a grate on them like the floor drains do. So anything can get down that 2-inch hole, or some floor sinks are 3 to 4. And so that's one reason is that you want to make sure that floor sink is at least sitting above tile height on the floor. Anything else, Ken?
Nope, that's good.
So when we get into the commercial side of our kitchens, this is pretty much our layout. It's pretty much what it looks like underground. Everything is connected to a drain line. Kitchen drains usually normally run through or are supposed to run through a grease trap system. We will get into the whole grease trap system later on in the class, but if no one's familiar with, what each area is, so this here on the left is the floor sink that you'd find in these restaurants. And then we have drains like these with the trough drains. And the way to get into these is you just pull these grates off, and then you'll see the access to the drains. If you're ever dealing with, a trough drain like this. And then, of course, the floor drains, same thing. It's a 3-bolt 3-bolt system. And then, if everything's backing up, we all have seen these clean outs. It's just a brass cap cover on it. Usually they're labeled clean out on it, or they're just a plate on the ground like that. So that's just the basics of oh, shucks. What happened? So that's pretty much just the basics of light commercial plumbing. Let me get back over there. Dealing with the kitchen side of things. I couldn't really think of anything else we would have to deal with in dealing with any drains in a commercial style kitchen. Just that, we all remember that everything has a flood height. Water only seeks flood level. Everything is level. Water always sits level. So, if you walk into a kitchen like this, you see the floor sink backed up, you want to start walking around that kitchen and just see what else is backed up. If nothing else is backed up, you're dealing with just that floor sink. If you walk into this kitchen, you start seeing, you see the floor drains all backed up, and then you see floor sinks full. So now you got to go deal with, trying to find a clean out to, you already know that it's a mainline stoppage.
Josh, what drains go to the grease trap?
So the floor sinks, floor drains, the trough drains. The only ones that wouldn't go to the dishwasher and any kind of condensation drain.
You guys got that? So it's important to know the code is requiring dishwashers be independent and go straight to sewer. The theory, which is debatable, but it's still the code, is that the temperature of the dishwasher will solidify the mantle of the grease in the trap, allowing it to flow through and pass through the grease trap itself and enter into the sewage system. Which it's kind of a strange theory, but at the same time, it is the code. So dishwasher goes into sewer, and like Josh said, condensation needs to go to dry well. Actually, now not even into sewer either. But anything that has the potential of being in contact with fats, oils, and grease, you wash your hands. Something falls in the sink within the square walls of the kitchen. Is required to go to the grease trap.
Yeah, so if anybody missed that, the reason for the whole dishwasher is because they're preheated after being already distributed hot water. They get to a certain temperature to where it'll just, how he said, not solidify, but it'll break down the grease as it passes through the line, and it ends up letting the grease pass through the trap, and then it gets into the sewer line. So Connie, I've seen your hand up. You had a question?
Yeah, can you clarify, or if anybody else on Oahu knows, is that just a Maui thing, or is that a Maui and Oahu thing? Because I think Oahu is different.
Yeah, I do think the code on Oahu is different. I'm going to be out of touch on the Oahu code. Maybe somebody can chime in on that, but I just know that still standing on Maui. I think on Oahu, they are allowing the grease trap to go into, the dishwasher to go into the grease trap. I'm not 100% though. I would have to go and research that.
Yeah, I only bring that up because I know that there was a disparity between Maui's wastewater ideas on that some time ago, and which created a lot of confusion.
I agree. Anyway. Yeah, if I misspoke, then I stand corrected. But on Maui, it is a standing code. On Oahu, maybe ask Darren, ask Steve, or just ask somebody who is an inspector or somebody to find out. It's important to know, because if you're the one doing the installation, you're hooking something up, or in the future you want to know what you're tying into, and you want to make sure you're doing it properly.
Do any of our Oahu guys know if it's a code there of not having that dishwasher tie into the grease trap? I didn't even know that.
Yeah, I think Darren, I don't know if you're driving or what. Maybe Darren can answer. Eh? No?
Yeah, I don't think he's here. Oh,
I see
Darren's
his,
here.
yeah, I see his
Darren's
name
here.
up.
All right. So that pretty much takes us out of the light commercial side, trying to keep it as basic as possible. Which takes us into chapter 4, where
Josh, can I interject one time?
Yep.
One other small thing. Another little quirk on Maui is that on pre-rinse sinks, you're gonna find that another requirement for the wastewater, you guys will see it, is that on your rotary wastes, there needs to be outfitted a non-removable perforated screen. And that is something that's normally that needs to be put onto your 3 compartment sinks, as well as I think hand wash sinks as well. Just so that as you guys are replacing rotary wastes, that these 1/8 inch holes, I think is what they are, and it's got to be a particular gauge, and you need to drill through, you need to have it secured in a way that it's non-removable. You'll find that a lot of them are being ripped off and whatnot. Yeah, Ken's holding one up there. That's what they look like. So when you are doing replacements or dealing with that type of an issue, at least on Maui, again, I know Maui got quirky when the grease trap change happened back in the early 2000s and whatnot. So but just be aware of that as well.
I don't think it's a plumbing code. I think it's a health department. Yeah,
right.
it's not plumbing code, but health department, when they come and they do the inspection for any food service, that's a code that they put on them.
Thank you. Yeah. So just in case you guys, I think there was an instance I remember some time ago where we removed a set, we put, just back on a regular rotary waste, and we did not replace that, and then we had to go back and redo that. So it's just, let your customer know that that's part of it.
that brings up a good topic right there. Give me 1 second. So everybody knows what a rotary waste is, right? We see these under, commercial sinks, and they have this bar on it to where you're able to, turn it left to right to seal the drain in the sink. So does anybody know why those are required to have in sinks like that? And why they can't have just a basic, basket strainer? You can just put your own plug in it.
Are you asking? You're asking the question?
Yeah, I'm asking the question if anybody knows.
Gotcha. Well, you can ask somebody. Point somebody out.
Who is that? Sorry, I can't even see who's.
Brandon.
Oh, Brandon. What's up, man?
Yeah, from what I understand, it's for safety.
Correct.
From what?
From, when you're working with these sinks, usually you have to have the temperature really hot, or sometimes there's knives in the sink and you can't see it because of the soap. So if you want to drain the sink, if you have a stopper on the bottom of the sink, you could be sticking your hand into hot water or into knives. So the rotary waste is an exterior way to drain the sink without shoving your hand.
What's the temperature that should be being distributed to that sink?
I think it has to be at least 130. for the
What?
sanitation.
140.
140. Yeah.
Yeah. So that's 3rd-degree burns in a very short period of time. So that's a good answer, Brian. Temperature, and then the safety for sharp objects. Good job.
Job, Brandon. Yeah, guys, don't be afraid to just chime in. You know, if you feel that you know something, you want to get it out there, no worries. But yeah, those rotary drains are there for a reason, to protect yourself from burning hot water and also anything that could cut you or hurt you. Sticking your hand in a full sink of water, you don't know what's in there. But that's what those are there for. I know they're a pain to work with sometimes, but so we're gonna move into our drain book. Let me just get this figured out. Which takes us into the municipal part of our sewer systems. This chapter wasn't really that long, so I figured we could just read it together, because it really does talk about most of it in here. There wasn't that much, research we had to get into this, but just get this centered. Let's get a reader. I'll start it off for now. So municipal sewer systems is the largest of all sewer systems. There are 3 types of municipal sewer systems in existence today. There's sanitary sewer systems, storm sewer systems, and combination sewer systems. Sanitary sewer collects waterborne waste and liquids from residential, commercial, institutional, and industrial sources and transport them to a municipal wastewater treatment plant. The purpose of the sanitary sewer system is to provide a sanitary situation for the general public, one free from disease-carrying microorganisms. So the first one, they're talking about the sanitary sewer systems, which is our county sewer drains, where all of our, residential, for those who have a county tie-in. What is that? Which takes us into our second, which is a storm system. Storm sewer system is a sewer system which conveys stormwater runoff into streams and rivers. A stormwater drainage system for residents connect to the storm sewer, or simply soaked into the ground. Commercial and industrial buildings, stormwater drainage systems also connect to storm sewers. So commercial guys, they have their own system also. Most of them do run out into like the parking lot, or they do have a well, or they do have an actual storm drain that the county provides, and they deal with it out after that. And then the third type of municipal sewer system is called a combination sewer, which is called a combination because it functions as both sanitary sewer and stormwater. So this combination sewer system deals with both sewer, sanitary sewer, and stormwater. It also transports water and waste treatment plant. There are still approximately 5,000 combination sewers in existence in the United States. There are real problems for municipality and the Environmental Protection Agency. the EPA. The problem which concerns the EPA is not that only the health concerns, but also cost concerns, since a combination sewer ends at a wastewater treatment plant. All contents of the sewer must pass through the treatment plant. Once sanitary waste and storm waste are commingled by a combination sewer system, a health hazard exists. Because of the health hazards, all the waste must be treated. Stormwater must be processed along with the sanitary wastewater. There is a cost involved every time a gallon of water passes through a treatment plant. Why should taxpayers pay to treat uncontaminated stormwater? The answer is that they should not have to pay to treat it. It is a waste of tax dollars. So, I mean, correct me if I'm wrong. There is a storm water collection facility that we have that is used to, you know, if anybody has seen these the purple, I think it is, Ken?
No, you're thinking of R1 that's reclaimed.
Right.
So that's when they're taking treated sewage and then utilizing that for like irrigation.
So not the stormwater.
Yeah, no, our storm system basically it exits out to the ocean because it is, it doesn't have fecal matter, bacteria that are, that's in, contaminating, water that needs to be treated. There was a time when they allowed it to connect, but like you said, and how you read it out, if you notice, every time you hear of a sewer spill, most of the time it's usually during the time of a heavy flood or a downfall. They really don't have a way to treat that much volume of water, and so they are stopping the connection of storm to sewer because of the amount of volume that you end up treating. But reclaimed water is different, separate from that. That's like a first stage treated water.
Okay. So, which, I mean, Ken pretty much explained this next paragraph. So when there are heavy downpours and there are combination sewers, the wastewater treatment plant gets a large surge of water, heading its way. The treatment plant must deal with the increase in water. Some have collection points to hold the water until it can be processed. Others at times are focused to open the bypass gates and allow the wastewater to flow directly into the rivers or streams to keep from flooding the treatment plant. Needless to say, the general public and the EPA are not pleased with this situation. The local media oftentimes pick up the situation and reports it. Now you understand why the EPA is involved. Combination sewers are slowly being replaced by individual sewer systems. So, like Ken said, you get a bunch of rain, we've all seen what rain can do. We've seen Haiku just flood out. I know Oahu had some flooding, and, just think about all that water going into a system and ending up at our treatment plant and just, causing our plant to overflow, and now all the sanitary and everything that gets involved in there, all the sanitary sewer, now contaminates everything around it, that it overflows into, whether it's the ocean, the rivers, or even our ground.
Well, a lot of times we go to jobs, residential, and I know we're talking municipal, but this ends up municipal, right? So you go on a residential job and somebody ties in a roof drain, roof gutter or something into the sewer system. Two problems at that. One, you're doing a direct connection to something that doesn't have a trap seal like we discussed earlier, right? And then the other problem is in heavy downpour, now you're adding, to the load of having to treat water that is not contaminated, but once it migrates or mingles with sewage, now it's contaminated. So now you just add it to a bunch more contaminated water.
Right. So a properly designed and sized sanitary sewer will handle peak loads and transport solids without leaving deposits in a pipe. As a rule of thumb, a sanitary sewer should not flow any slower than 2 feet per second when full to avoid settling of suspended solids. Grade and speed will vary. Municipal sewers are connected by a series of manholes. Manholes serve several functions. They offer an access point for cleaning purposes. They also provide a junction point for 2 or more branch sewers. A manhole also offers the engineer a chance to change the sewer pipe velocity. Manholes are supposed to be located at intervals of 300 feet or less. Unfortunately, this is not always the case. I have encountered numerous manholes 500 to 600 feet apart. Whenever there's a change of direction, you will find a manhole in a municipal sewer. In reality, manholes are straight runs when cleaning municipal sewers with high velocity water jets. The upstream manhole is located and the pipe is cleared from the lower manhole to higher manhole. We will get into techniques about the equipment and water jetting later in the book. So going into manholes, after the sewer main has exited the building and becomes, the lateral line. Before it exits the property, and some properties have manholes on their property, but you're not supposed to have a tie-in between each manhole. So there has to be a manhole on that tie-in. You're not supposed to take more than, I don't know if it's 90 degrees or a 45. They're supposed to be straight, right, Ken? On the manholes, between manholes, you're not supposed to have any turns or any change of direction. There's supposed to be a manhole on that specific point of the drain. So you shouldn't be seeing tie-ins, anything, I know we see tie-ins before the manholes or whatever, but once you hit a manhole, from that manhole to the next manhole, you shouldn't have any tie-ins. You shouldn't have any change of direction. And they are, it's supposed to be within 300 feet or less, but we've all seen them further away from each other than that.
Yeah, that job we did at Maui High was a good example. Remember that one tie-in they had in between the 2 manholes?
Yep.
And so that was that was tricky. Made no sense because the manhole wasn't that far away from it. So the potential of them tying directly into it was actually pretty great. But anyway.
Yeah, and that was more in the property kind of deal. But I think they're talking about the more on the county side of everything. We shouldn't be seeing things like that. And it's just for us to know what we're dealing with when we're getting into, the municipal side of drain cleaning, when we are going to have to get into manholes, is that we know that any change of direction, there should be a manhole. Tie-ins, there should be a manhole, just so that we're all aware of certain situations. So we're at 7:45. I want to move on to the other half of this municipal sewer systems chapter. And then I forgot to tell everybody to bring their book, but next week, if everybody could bring their book in, we're just going to read through this. It's going to go through the type of pipes that are used for lateral drains, how to get rid of, deal with certain situations on dealing with, big drains like this. But other than that, that'll be the end of class today. Happy 420. Hope everybody has a great day today, and we will see you Thursday.
Hey, Josh,
Shoot, it's
thank you.
about as
Thank you, Josh.
right,
Josh, thank
And
you.
sisters.
and sisters, yes. So,